Hello, pre-algebra students. Today we're going to take some notes, and we're in our probability unit. So it's probability, and it's our second set of notes. So notes, probability, number 2. The topic of the day, combinations. Combinations. So your learning objectives, you need to know what combinations are, and you need to be able to correctly use the formula. So first of all, what is a combination? It's a grouping of items, and in this grouping it doesn't matter what order you put it in. So order is not important. Order is not important. Order is not important. Okay? So a combination is a grouping, a list of items where you can switch the order. It doesn't matter. Order is not important. It doesn't make a difference. Alright, for example, let's say you had, example number 1. Let's say you were going into an ice cream store and there were 6 flavors that you could choose from, and you were allowed to get 2 scoops. And for this example, let's say you can't get repeats, so you can't get like 2 vanillas. You have to get 2 different scoops. Alright, that would be an example of combinations. It doesn't matter what order I put the 2 scoops on. I could put the vanilla on first, then the chocolate, or I could put the chocolate on, then the vanilla. It's the same ice cream order. Alright, so let's say you had lemon, strawberry, vanilla, peach, chocolate, and Moose Tracks. If you want 2 scoops, you could get lemon and strawberry, lemon and vanilla, lemon and peach, lemon and chocolate, or lemon and Moose Tracks. Now, I'm trying to make an organized list here. I could write strawberry lemon, but that I don't need to. I already have the strawberry and the lemon combination. See, even though the order's changed, it doesn't make a difference. That's the same ice cream order. So I don't want this one. But I'm going to have strawberry, maybe vanilla, strawberry peach, strawberry chocolate, strawberry Moose Tracks. Now with vanilla, I'm not going to write vanilla lemon. I already have vanilla and lemon. That's the same ice cream cone. I'm also not going to write vanilla and strawberry. I already have vanilla and strawberry listed. Those are the same combinations. So I don't want those two. The order is switched around, and that doesn't matter. It's the same order of ice cream. Alright, so I need vanilla and peach, vanilla and chocolate, vanilla and Moose Tracks. Then I need peach and chocolate, peach and Moose Tracks. And finally I need chocolate and Moose Tracks. And that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, what they're called is combinations. These 3 get eliminated because they're not really a different combination. Okay, so out of these flavors of ice cream, I ended up with 15 combinations. Alright, so sometimes it's hard to do making an organized list, so there's a formula. So let's see how that goes. So in the formula, what you do is you say I have 6 flavors of ice cream. I want to find all the combinations, taking them 2 at a time. So there's 6 total, and I'm going to take them 2 at a time. And here's how it works. What you do is you'll write 6 factorial, what you say is factorial, divided by, and then now you subtract the 6 and the 2, factorial, and then 2 factorial. Alright, so that exclamation point, what you say is factorial. Let's write it over here. Factorial. And all you do is just count down and multiply. So 6 factorial, what that means is 6 times 5 times 4 times 3 times 2 times 1. Now underneath, 6 minus 2 is 4, and now I need 4 factorial. So count down from 4. 4 times 3 times 2 times 1 times, because they're right next to each other, so you multiply it. Now 2 factorial, just count down from 2. 2 times 1. All right, now you can reduce. You can reduce things because everything is being multiplied. You're allowed to cancel. So I'm going to cancel 4 times 3 times 2 times 1, because here's the same exact thing. And then I'm going to have on the top here, I have 6 times 5, which is 30. Whoops. Underneath, I have 2 times 1, which is 2. And 30 divided by 2 is 15, just like I figured out already. There are 15 combinations. 15 combinations. All right, let's try another example. Example number 2. All right, let's say you have 30 kids, like in this room, approximately 30 students. Sorry, just, yeah, like we have in a classroom. And let's say I want to put you in groups of 4. Okay, that would take a while to list all the combinations. Now, once you're in a group of students, if you're sitting with 4 people, and I call you like group 1, it doesn't matter what order I call your names. I could say Sally, Sherry, Joe, and Tim. Or I can mix it up and say Joe, Tim, Sally, Sherry. It's the same group. So this is a combination because I can switch the order and it doesn't matter. It's still the same group. All right, I don't want to list all these. I'm going to use the formula. So here we go. There are 30 altogether, and I want to take the combinations of 4 at a time. All right, the first thing you do is you take the first number, which is the total, and write that in the numerator, 30 factorial. Underneath, you subtract these two. 30 minus 4, put that in parentheses, factorial, and then finally 4 factorial. Okay, factorial means you just multiply, just counting down, all right? So here we go. I'm going to take, okay, from 30, that's a lot, so you're going to see a little shortcut here. 30 times 29 times 28 times 27 times 26 times 25 times 24, and that's going to keep on going all the way down to 1. All right, I ran out of room. That's okay. Now, 30 minus 4 is 26 factorial. So I'm going to go 26 times 25 times 24 times 23, and I'm going to keep going, but I don't really want to write them all. I know it goes all the way down to 1, and then I have 4 factorial. 4 times 3 times 2 times 1. Okay, now I can cancel. Anytime there's multiplication in a fraction, you can cancel. So look, this goes from 26 all the way down to 1, even though I didn't write them all. This goes from 26 all the way down to 1. They cancel. Now I have some rather large numbers to multiply. Grab a calculator. I multiply those out, and I would get 657,720. Underneath, 4 times 3 is 12, times 2 is 24. And now I divide. And there are actually 27,405 different groups, different combinations of groups. Wow, there's 27,405 different groupings of students in a classroom. And remember, it doesn't matter what order I name you in, you're still the same group. All right, we'll try one more example. So last example, let's say that there are, so this is example number 3. Let's say there are 23 kids, or people. 23 people, kids, going on a trip maybe, and they have to be in groups of 3. Okay, this is a combination because it does. If this is your group, Sarah, Sheila, and Chris, and I name them in another order: Chris, Sheila, and Sarah. That's still the same group. It doesn't matter what order I say the names. This group and this group are the same group. So order doesn't matter. That's a combination. Great. Use the formula. There's 23 people. We want to take them in combinations of 3 at a time. All right, you take the first number, 23, and write factorial. Then next, you subtract these two in parentheses, 23 minus 3, factorial. And then you take the last number, 3 factorial. All right, here we go. 23 factorial means you multiply and you count down. 23 times 22 times 21 times 20 times 19 times 18 times 17 times 16 times 15, all the way down to 1. Next, 23 minus 3. 23 minus 3 is 20 factorial. So you do the parentheses, you get 20 factorial. 20, 19, 18, 17, 16, 15. Okay, I'm kind of running out of room. I know it'll go all the way down to 1. And then I can't forget 3 factorial. 3, 2, 1. And now I cancel. This would go all the way down to 1. This part would go all the way down to 1 starting at 20. This would go all the way down to 1. Now in the numerator, I have 23 times 22 times 21. I grab a calculator. And that equals 10,626. In the denominator, I have 3 times 2 still. That doesn't cancel. Remember, this would go all the way down to 1 all by itself. I ran out of room. That's the part that canceled, but I still have this 3 times 2, which is 6. I grab a calculator, I divide. There are 1,771 different combinations, or groups. Combinations or groups. Alright, I hope this is helpful for you to try some problems on your own. Good luck!